Hi, my name is Akhil Sabdel. I am from Aeronautical Engineering. My topic is about solid rocket motor components, which describes about the components of the solid rocket motor. A solid rocket motor is a rocket with a motor that uses solid propellants. Simple solid rocket consists of motor, casing, nozzle, grain, and the igniter. And the grain is also called as the propeller charger. A solid rocket motor contains these parts like we see in the igniter, thrust terminator, motor case, internal insulator, thrust vector control, nozzle throat, propeller gain, thrust vector accumulator. These are some basic parts of the solid rocket motor. Motor. Conceptually, solid rocket motor are simple devices with very few moving parts. An electrical signal is sent to the igniter which creates hot gases which ignite the main propellant gain. This is a schematic diagram of the solid rocket motor. Cutaway view of a solid rocket motor showing solid rocket motor propellant and its field joints. These are some parts of the solid rocket motor. Casing. Casing may be constructed from a range of materials. Cardboard is used for small black powder model motors, and aluminum is used for large composite fuel body motors. Steel is used for the space shuttle booster. Filament wood, granite, epoxy casing are used for high performance motors. Casing must be designed to withstand the pressure and resulting stresses of the rocket motor. The casing serves as a highly loaded pressure vessels. Typical large solid rocket motor made up of welders. Yes, typical solid rocket motors. We have seen the igniter assemble and the thrust terminator portal. We have to assemble the parts. Another component is a nozzle. The supersonic nozzle provides for the extension and the acceleration of the hot gases and has to withstand the serve involvement of the high heat transfer and erosion. Nozzle range is size from 0.05 in throw diameter is about 54 in which operation duration of a fraction of a second to several minutes. Nozzle for solid rocket motors can be classified into five categories. They are fixed nozzle, movable nozzle, submerged nozzles, extendable nozzles, and the blast tube mounted nozzles. Simple diagram of five common nozzles configuration. There is the first one is the fixed nozzle which have fixed parts, and second one is a movable nozzle with flexible joints allow controlled diffusion of the thrust axis and this allow vehicle maneuverability. And the submerged nozzle which is shown in C, and D is about the extendable exhaust cone. After sledging concept allow large nozzle at high altitude but minimize vehicle length and volume during the ascent. And the E part is the nozzle with the blast tube concentrated in some typical mass for balancing the center of the gravity. And some of the nozzles in conventional bell at sea level, at vacuum, and dual bell, extension and deflection. These are the different shapes of the nozzles. And, and last part is the igniter. Igniter process of a solid rocket motor occurs in a very short time interval of about 200 milliseconds. The igniter will burn in 200 milliseconds of time. Although the process is very fast, it is still complicated and a composed of two phases. The first phase is a igniter of the motor igniter, which is essentially a small rocket motor position inside the bigger rocket motor. In the second phase of the igniter, the propellant surface starts burning and the flow field is dominated by the mass flow injected from the propellant. In this phase, the motor chamber is filled with burning gas, and the motor pressure rises sharply from the ambient pressure to the motor working pressure. And the next component is grains. Solid fuel grains are usually molded from a thermoset, elastomers, fuels, oxidizers, and the casting. Al- Aluminium perchloride is the most common oxidizer used in these grains. This fuel mixture is known as the ammonium per, mm, perchloride composite propellant APCP. The grain is cast in different forms of different purpose. Slow long running slow long running rockets have a cylindrical shaped grains burning from the one end of the other. Most grains, however, are cast with a hollow cone burning inside out of as well as the end. The thrust profile over time can be controlled by grain geometry. Example, a star-shaped core will have greater essential thrust because of the additional surface area. As the star point has burned up the surface area, the thrust are reduced. Some solid rocket motors, such as the one used in AGM 114 Hellfire mission, and utilizes a rod and tube gain design. Thank you. This is about my concept video.